Hello guys, another example on analyzing RC circuits. As with every other RC circuits, the first thing we need to do is to find the voltage across this resistor before time t0 when the switch is in this position. So in this state, the capacitor works as an open circuit. In order to find the value of voltage across this resistor in this point, there are two approaches to finding this problem because we have two different power sources. The first one is using the superposition theorem. To apply superposition theorem, you need to calculate the voltage across this resistor created by individual power sources, and you need to sum them up later. So in this case, you need to short circuit this power source, and you only need to consider about the voltage created by this source. So since this is 1 ohm, because this is 2 ohms in parallel, and this is 3 ohms together, using the simple voltage divider, you can easily find out the voltage across this resistor equals 3 volts. Okay. For this circuit, this is 3 ohms, and this is 2 ohms, and you can think of these two resistors being in parallel, so it's 6/5 ohms, with 2 ohms being in parallel. So using the voltage divider again, you get 3 volts. So adding these up, you get 6 volts across this capacitor. This resistor, I mean. Next, we want to find out the value across the voltage value across this resistor after time t0. In order to find this, we need to use this equation. Now, this equation is quite different from the equation that we used before, which looked something like this. And this is actually a short version of the original equation, and the equation that we need to memorize is, in fact, this equation. And I'll show you why this is in the next video. But for the time being, I want you to memorize this equation and use this, because this is the only equation that we need to memorize in order to solve any other RC circuits. So this right here is the voltage value when time goes into infinity. And this right here is, in fact, the voltage value right after the switch is turned on. So this is different from, this can be different in some cases from 0 minus, which is the voltage just before the switch is turned on. So we are trying to find out the value of this. So in order to find this value, we need to redraw the circuit. Now since the switch is turned on, this is now an open circuit, and just after time t0, the capacitor will work as a voltage source because it is able to store a voltage for a short amount of time. When we redraw the circuit, it looks something like this, but except that we don't know the voltage of this power source, so we need to find the voltage value of this capacitor just before time t0, because voltage across capacitors cannot change instantly. Okay. Now I told you that these two things are not always the same. Now this only applies for resistors and other components. For capacitors, this is always true because capacitors resist sudden changes in voltage value. So in order for us to find the value of voltage at time t0 plus, So in order for us to find the voltage across this capacitor, we need to use the original circuit. And to solve this problem, we can use the superposition theorem. And the two circuits that we will get from superposition theorem will look like this. Well, the first circuit created by this 12 volts voltage source would look like this. And since these two resistors are in parallel, they would sum up to 1 ohms. If you use the voltage divider to find the voltage at this point, it is 9 volts at this point. The second circuit created by this 8 volt voltage source would look like this. We are still trying to find out the value of voltage at this point. In order to find the value of voltage at this point, we need to calculate this part first. We can see that since this is an open circuit, we can sum these two resistors up because they're in series, and this would become 3 ohms. And since these two resistors are in parallel, when we calculate these two resistors, it becomes 6/5 ohms. So using the voltage divider with 2 ohms and 6/5 ohms, we can find out that this corresponds to 3 volts. And using the voltage divider on these two resistors, we can easily find our final solution on this node to be 1 volt. And adding these two values up, we can find out the initial voltage to be 10 volts. So this would become a 10 volts voltage source. Okay? And at 10 volts, the value across this resistor would correspond to the value of 5 volts. Because these two resistors are in series, we can use the voltage divider. The next thing we want to find out is the voltage when time goes to infinity. So in order for us to find this, we need to redraw the circuit again. When time goes to infinity, the capacitor no longer has any energy, so it would work as an open circuit. So the circuit would look simply like this, and using the voltage divider, we can see that the final voltage that we get is 24/5 volts. The last thing we need to find is the time constant, which is the Thevenin resistance times capacitance. Now we need to find the important thing to note is that we are not trying to find the Thevenin equivalent resistance at this point. We are trying to find the value of RTH from this point. So if you redraw the circuit, it would look something like this. And since these two resistors are in series and these two are in parallel, the final value that we get is this. So the time constant in this case would correspond to this value. So the final equation that we obtain from this equation is this value. And this is your final answer.